Okay, we're going to do a quick review of some geometry stuff, starting with triangles. Triangles, on the inside, all of the degrees add up to 180 degrees. Triangles are three-sided polygons. It's two-dimensional, so it doesn't have depth. And there are three types, essentially. There's an equilateral triangle where all sides are congruent and all angles are 60 degrees. There is a scalene triangle where all sides and all angles are different, are not congruent. And then there is the isosceles where two of the sides are congruent and the opposing angles of those two sides are congruent, and that is called an isosceles. I think I have it someplace else. Okay, we can also classify triangles by angles. There's the acute triangle where all angles are the angles are less than 90 degrees. That looks kind of weird, but I'll call them X. All angles are less than 90 degrees. Then there's the obtuse, where one of the angles is, here, I'll put less than 90 degrees right there, where one of the angles is greater than 90, and then one right angle, which is exactly equal to 90 degrees. All right, so scalene triangles have three different sides, side measures, and three different angle measures. And then again, the isosceles, two sides are congruent and their opposing angles. Remember, I drew that. So these two angles are congruent and those two opposite sides are congruent. And then equilateral, all three sides and all three angles are the same. So each of these angles are 60 degrees. Regardless of the side lengths could all be 10 inches, could be 20 miles. The side lengths could I don't know what the side lengths will, but for an equilateral triangle, always the angles are 60 degrees. All right, and then here are the formulas. To find the perimeter of a triangle, you just add up the three sides. And to find the angle, the area, excuse me, you take half of the base times the height. So if you've got a triangle that looks like this, hopefully you're given the height and you're given the base, and then you take half of the base measure and multiply it by the height, but usually it's just written like this. Okay, then I'm going to move up here and we're going to talk about quadrilaterals. Quadrilaterals have four angles, and their four angles measure up to be 360 degrees. So think about that. If you've got a square, and in a square you've got four right angles, 4 times 90 degrees is 360 degrees. Okay, here are the formulas. So the perimeter of a square is you take whatever the side is. There's a side, and remember, all the sides are the same. So side plus side plus side plus side, well, that's 4 of them. So it's just 4 times the side measure. And then for the area, this normally is length, this normally is width. Well, in this case, for a square, those measures are the same. We just call them the side measure. So it's side squared. And then, let's see what other key. For a rectangle, notice you've got two lengths that are the same and two widths that are the same. So if you were to start here, find the perimeter, you take a tape measure there, there's one length, measure there, that's one width, measure there, that's another length, so there's two of those, and then another width. So the perimeter of a rectangle is just 2 times the length plus 2 times the width, or we could call this base and we could call this height, and it'd be 2 times the base plus 2 times the height. The area is just length times width, or sometimes you're going to see it as base times height. They mean the same thing, just sometimes this measure is referred to as length, or sometimes this measure is referred to as the base. All right, let's come over here. Oh, circle. Circle with center C and radius R. The circumference, notice formulas are usually capital letters, uppercase letters, is 2 pi times the radius. Or, since radius is half of the diameter, or in this case, the diameter is twice the radius, notice twice the radius equals the diameter. So if you know the diameter of a circle, just take the diameter and multiply it by pi, and that will give you the circumference. But for the area, you do need to have it in radius form. Well, I guess you could do this, but if you're going to do that, you might as well, because diameter divided by 2 is the radius, but you could write it like that. All right, so that's the circle. The rhombus, all opposing angles, so this angle and this angle are congruent, this angle and this angle are congruent. And then this is how you find the area. 1/2 of the first diagonal multiplied by the second diagonal. So hopefully you'll be given that information. For a trapezoid, you need to know how to label all the parts. Normally the shorter base is base 1, but they could call it base 2. Then this would be base 1. And I'd name this base 1, this is base 2. And a line coming from the top base down to the lower base, the shorter base to the longer base, a perpendicular height or perpendicular line is called the height. And here is the formula. 1/2 times height, and then multiply that by, add the two bases together. And really what's happening is you're multiplying the height by, you're finding the average of the bases. Base 1 plus base 2. And remember, to find the average, you take the sum and then divide it by the number, and there's 2 sides. So divide it by 2. But this is kind of a traditional way. But if you want to think about it this way, add the two bases together, divide it in half, then multiply it by height. That's how you find the area of a trapezoid. Parallelogram, you're going to have to find the height, and then you're going to treat it almost like a rectangle, but it will definitely be called the base times the height. So here's the height. This is called the base. So if they call, see, in this case, they won't really have a width because the sides are at a slant. So for parallelograms that are slanted, because by the way, a rectangle is also a parallelogram where the sides haven't been slanted. Anyway, for a parallelogram that looks like this, here is the area, and for the perimeter, you just add up all the sides. Okay. Let's see. For volume, it's just the area formulas times the third dimension. So it's the area of this square. So if this is a cube, the area of this square is side squared. So the volume would be side cube, because this side is also the same if it's a cube. If it's prism, a rectangular prism, where the length, the width, and the height are all different, then volume, remember, area is length times width. For volume, you're just going to multiply the height. So it's the area formulas multiplied by that third dimension. For a sphere, though, that's where you've taken this flat square and now you've inflated it. And so it's like a basketball or volleyball or golf ball or whatever. This is the volume to find a sphere. So you definitely need a radius on this. Okay, and here's the surface area formula. I'm not sure that they'll give you any of those on the SAT or PSAT, but here is the formula for the surface area. So if you were to take a basketball, any kind of, sphere, and you were going to do kind of like a paper mache, and you had to cover the entire outside, that's what the surface area is, the entire outside area covered. Okay, here is the formula for volume of a cylinder. Well, notice it's the area formula of a circle, pi r squared, but then times height, and you get volume. For a cone, similar to a sphere, it's a take off. It's going to be essentially 1/3 the area or the volume of a cylinder. So instead of being radius cubed, you multiply it by whatever the height is. So it's 1/3 pi r squared times the height. Let's see, triangular prism. Here's the formula for that. I'm not going to go into depth in that here. We're already at 12 minutes. Here's Pythagorean theorem again, in case you have a missing side. So if you need to find the hypotenuse length, so if you had, say this is 4, this is 3, so it's 3 squared plus 4 squared, that's going to equal c squared. And then you'll find that c is equal to 5. Okay, rectangular pyramid. There's the formula for that. You could probably find some review problems just on Google. Rectangular pyramid problems. Let's see, triangular. So notice the difference between the two. The triangular pyramid, the base is a triangle. And for rectangular pyramid, the base will be a square or a rectangle. Make that smaller. Those are the two formulas. And then some important things to remember. So theorems, triangle sum theorem just means when you add up all the angles of a triangle, they add up to 180. So if you had a 60-degree angle and a 80-degree angle, I did not do this very well. This is probably a 25-degree angle, and let's call this a 75-degree angle. Well, that would help you find the third. So 25 degrees plus 75 degrees plus that third angle, we'll call it C, is equal to 180 degrees. Well, these two equal 100, so we'll subtract 100 degrees from both sides. That third angle is going to equal 80 degrees. Okay, here's some for some congruency laws to know if triangles are congruent. You know that two triangles are congruent if all three sides are congruent. And this would be one way you could show that. You know, two triangles are congruent if a side is congruent to a corresponding side of a triangle. The angle that's beside them, if those two things are congruent, and then the next angle. So literally it's a side, an angle, and then a side. And if those are corresponding side, angle, side, side, angle, side, if those corresponding things are congruent, then you know that those two triangles are congruent. Then you've got angle, side, angle. So you've got, oh, I misdrew this. It should have been here and here. So notice an angle, a side, and an angle consecutively. 1, 2, 3. If you have that situation of two triangles, then you know those triangles are congruent. And then angle, side, angle. Oh, darn it. This is where I mislabeled it. So I originally had it, so I had this. I had angle, angle, side. I just wrote it wrong down here. So that's one of the congruency. So if you've got an angle, not this side that's between them, but then you jump to the other angle, then a side, angle, angle, side, then of corresponding triangles, then the triangles are congruent. Then we've got angle, side, angle. So angle, side, angle, congruency, and then the hypotenuse leg, because the only time that works, normally teachers put it like this, the only time this theorem works is if you've got a right triangle, because if you don't have a right triangle, you don't want to make this of yourself. So we don't typically use that in classes. And it's because it doesn't work. It only works when it's a right triangle, so they renamed it hypotenuse leg. This was not what it was called when I was in high school. They called it this, but they said be really, really careful because it doesn't always work. And but it works each time if it's hypotenuse leg. So if two triangles, their hypotenuses are the same, and they're both right triangles, and then one of the other legs, so you've got a hypotenuse and a leg, a hypotenuse and a leg, and the right angle, because notice that side, side, angle, or angle, side, side, it only works for right triangles, and we now call it hypotenuse leg. All right, this is 18 minutes, this is way too long, so I'm going to end that. But this is kind of just, in a nutshell, a quick review of geometry. Oh, one last thing. Polygons, if you're trying to find polygons. So the degrees inside the polygon, you take 180 degrees, and the number of sides, subtract 2. So if you've got a hexagon, so that's 6 sides, 6 subtract 2 is 4. So for a hexagon, 180 times 4 is 720 degrees. So all of these angles add up, the angles, the angle sum add up to 720 degrees. All right. To find the degree of the interior angle, you take the same formula that we just had and divide it by the number of sides. So in this case, we'd take that 720, there are 6 sides, we would divide that by 6. So each of the interior angles right there are all 120 degrees. And then to find the exterior, well, all exterior angles of a polygon add up to 360. So take that 360 and divide it by the number of sides. So 360 divided by 6 sides, you're going to get 60 degrees. But another way to think about it is if here's a hexagon, 120. if we extend the side, so here's the exterior angle, well, look at 120 plus 60 add up to this straight line, 180. But anyway, that's it.